welcome on in, everybody. I think we're set right. I am getting over a cold, so if I don't sound right, it's just because I'm struggling not to lose my voice today, teaching 3 classes and having a cold. So, moving ahead, things I want to get into. So, I'm starting to get questions and emails about the final and stuff like that. So let's go over that so everyone's kind of understanding what the expectations are, and then you don't have to get nervous or anything. We'll talk about it. So, if you're on the main Ventura College webpage, so this is just venturacollege.edu, right? Just the basic webpage. Notice up at the top there's a link for academic calendars. I recommend that every semester you go in here and you print 2 things off. Okay, my students who do this, I have students who'll take like a binder, and you ever see those binders with the sleeve? They'll put these 2 schedules in the sleeve, and they look at it all the time, and so they know what's going on. They know what days are holidays. They know when their final exams are, all that kind of stuff. So go in here, click academic calendar. 2 things you want to realize. Okay, so I'm going to go over the instructional calendar first. This is super helpful to know, especially if you're still in high school and then you're coming to the college as a sort of supplementary to your high school experience. Sometimes students don't understand the differences between college and high school, and so they can get confused. So, this is our fall 2021. So this is the semester we've been working through. We just had these gray holidays right here in November. We're on November 30th. The end of this blue period, that's the end of regularly scheduled classes. The purple is finals week. So sometimes people will book things for the 9th. They're like, oh, my Disney cruise starts on the 9th. And then they don't realize their finals on the 10th or the 13th or something like that, right? There's been issues like that. And then people ended up with regrets, okay? So just realize the 8th is not necessarily the last day of your responsibilities in your course, okay? The way we're doing it now, you can take your test a few days early and finish it up, but you don't have to. So I'll go over that in a little bit. So the purple is finals week. So technically the semester is done on the 15th. At the end of the day on the 15th, semester is over, okay? So just kind of be aware that's the timeline we're on. So this is a Tuesday, Thursday class, meaning we meet today, the 30th. We'll meet again on Thursday, the 2nd. We'll meet again on Tuesday, the 7th, and that's the last class meeting that we have. Office hours will take place as normal up to and including the 8th. So as long as it's blue, the regular semester, office hours will happen. Office hours do not take place in the purple week because the schedules go completely weird in the purple week, right? So, you don't show up to your regularly scheduled classes or your regularly scheduled office hours. So if you have questions, you should try to get a hold of me now in office hours in the next week so that I can answer any of those questions for you. Now, if you have an emergency, you can try to get a hold of me during finals week, and I can try to see if we can set up a time to meet, or I can try to respond to your email. But the schedules of everyone, you know how it is. Sometimes you may have to change your work schedule because your final schedules are weird times, and then you have to work that out. Same thing for us professors. Our finals are happening at weird times, and different stuff is going on. And then we have to get grades in as soon as we can. So we're trying to get everything completed. So pay attention to those homework dates because, as some of you know, you've been able to do past due assignments for 50% credit. That's about to end. I think it's either the 7th or 8th where that ends. So after that, you won't get to work on those past due assignments anymore. Okay, so do it now. You've got a week. Do it now before we get there. So then you say, okay, well, there's this whole purple week. When's my final? Great question. That's the other thing you should print out and have available. So right here, final exam schedule. Now, they used to print these before the semester started, which was nice because we're supposed to put the final exam time and date in our syllabus, except now we have to turn our syllabus in about 2.5 months before they release the final exam schedule. So that's kind of a weird thing. I'm supposed to have information the school hasn't released yet. But anyways, it's released now, and so you can figure out when your final exam is. This is not just for my class. This is for the whole school. So you click this, and then, you can see here the columns are days and the rows are times. So it's pretty straightforward. You find when your class is. So what are we, a Tuesday, Thursday, 10 o'clock class? Okay, Tuesday, Thursday at 10 a.m. There we go. There's your time. So that means that your final exam is on December 14th between 10:15 and 12:15. So that's obviously not a normal class meeting time. That's a final exam class meeting time. Now, here's the thing. You may have already finished the class by then, because what we're going to do for the final exam will be similar to what we did earlier. Now, actually, I think this is the class where no one had to do a retake, right? Which is awesome. So that's great. That gives me hope that you will all do well on the final, because you don't get a retake on the final exam. I don't offer one. There'd be too many issues with trying to do that for a final exam. But so I did it for the midterm, but I don't think anyone needed it. So you definitely do not get any retake for the final exam, but there will be a practice test for the final exam a few days ahead of time, kind of maybe early to mid next week. And then, let's see, so this is kind of towards the end. You will have a regular exam that you're going to work through. You took it just like your midterm. It'll be similar, slightly different, but, it'll be the new math, mostly the new math that we've learned since then, but a little bit of material from the first half of the semester as well. But I'll have a test set up like that. You'll do the test, but it has to be turned in by 12:15 p.m. on Tuesday, 12:14. So those kind of almost match up. So on 12:14, it's due at 12:15. This is not a rule that I get to break at my discretion. This is not a rule where I can say, oh, I'm just going to be the nice guy and I'll let you turn it in late. That's okay. There's school policies against that. So I just want to point this out. This is school policy, not my policy. Student request for early or late examination. Students requesting early or late exams may obtain a petition from the division office. Approved petitions are to be filed in the office of the division dean prior to the exam date. No exceptions, in bold, right? That's like the boldest thing on the whole, except for the title. It's the boldest thing on the whole page. No exceptions, right? So when the student goes in and tells the dean, hey, I messed up and I booked my Disney cruise the day before the final, you're not getting the dean's signature, right? So you have to get my signature and the dean's signature, and we don't generally do that because this has literally happened numerous times. There's people come to me about their Disney cruises happening at a bad date. That's not really a good reason to get an exemption, right? The two exemptions that in my 8 years at Ventura College, I guess we're in year 9 now, the 2 times we've exempted a student, and both the dean and I agreed we should sign that form. Both times it was a woman who was giving birth in the hospital during the final exam. So I think we can all agree that if someone is giving birth in the hospital or having major surgery or something like that, yeah, okay, we'll set it up so you can take the exam at a later time. But your poor planning and you planned a vacation in the middle of finals week, it's not really on the same level as giving birth, right? Not really the same thing. So just kind of be aware of that and make sure that now you can take that test early if you want. So you kind of have a flexibility right now that's going to start going away in the spring because they're starting to push back towards more on-campus classes in the spring. So we'll in some ways be going back to the old ways of classes, but the reality is we're never going back to the way it was before. But it won't be like this where everything's 100% online. We'll start to see more hybrid classes and stuff like that. Anyways, so the idea is, what you understand the point I'm trying to get at, this no exceptions, that means you can't finish your test late, okay? The test will close at 12:15 on this day, and if you have not taken the test, you will not be taking the test. It's the same thing as not showing up the day of the final. You're out of luck. Because otherwise, and it's not just about me being nice, I'm going to have to sit there and explain to my dean why I'm breaking the school policies. Yeah, I'm not going to do that, right? I'm an employee of the school. I have to follow the school policies. I have a contract. There's certain things I have to do. So I have to follow this. So unless you have some kind of major medical condition that legitimately excludes you from being able to finish something at a certain time, make sure you get that test in on time, okay? Because it will not be accepted late, and you don't want to have to take this class over again. No one wants you to have to take this class over again. So basically, don't wait till the last minute, right? There's a thing I see my students do sometimes that I've been telling my class about yesterday and today, which is basically half the problems that come up from students, or more than half, really come up from, obviously it's legitimately challenging to take a math class, but a lot of the struggles I see students going through are sort of self-imposed, right? They're trying to do as little work as possible. They're trying to see if they can pass the class doing the smallest amount of homework that they can. Well, that's not really great. And then also, someone's not going to give you an exception for doing like the littlest amount of work you can, right? So what you want to do is just avoid that cutoff. So if your stuff is due at 12:15 on Tuesday, what a lot of students do is they just pretend it's due Monday, right? So you just do your stuff a day earlier, you get it done, and you turn it in Monday instead. And then if something goes wrong on Monday, where the power is out, or your computer busted, right? Your computer fried, or your internet's down, or something weird happens, your car breaks down and you weren't able to get to your house in time to send the file or take the test, whatever you have to do, it's not a problem because it's really due the next day on Tuesday and you can still take care of that. The problem arises for many students. I get these panicked emails where it's 12:17 and some students like, oh, I was trying to get it in on time and I didn't do it. Yeah, you didn't do it is the key phrase there. You didn't do it. So make sure you finish this ahead of time. You will have numerous days in which to finish it. I'll give you a window of a couple days, but it's got to be wrapped up by 12:15. There is no points that can be earned after that time. And I know it sounds like I'm repeating myself. I'm repeating myself because if I don't, I'm just going to get a bunch of emails about people that, oh, I forgot when it was or something. And then it's a bummer. I don't want to give people Fs, and you don't want to get Fs, right? And this class especially has been doing pretty good. So let's just make sure we finish strong so that I can give you all passing grades and justify that you all earned those passing grades. And then you can take your math 3 and get your math all taken care of for high school and, some for college and stuff like that. So that's sort of the bottom line. Make sure you get your final completed. So the practice exam will come out sometime next week. Give you a few days to work on that. Then I'll post the actual exam. Take it when you feel is best for you. Just like I said with the midterm. Pick a time. Pick a time when you feel you're going to be relaxed. The kids aren't going to be asking you to make dinner. There's no distractions going on. Work's not bothering you. You didn't just work 8 hours waiting tables and then you come home and you're trying to do a test, right? I mean, I remember so exhausted, working 12-hour shifts at restaurants and stuff. And then you get home, there's just no energy for taking an exam, especially a final exam. So try to pick a time when you're going to be fresh, you're going to be relaxed, you're going to be able to work through this stuff without distractions. Take the test, do it. Don't do it at the last minute. I would recommend you don't even do it on Tuesday. Do it at least on Monday or earlier. Then you don't have to worry about any problems, right? So does everyone understand about how the final works? No questions about that? Okay, and then I should be able to have your grades submitted shortly after that the final exams are due, right? I have in a number of my classes, I have students who are going to be turning things in early, so I will be trying to calculate grades early so that as soon as I can, once all the grades are in, I can submit those grades because everyone wants grades in early, right? Students want them in early. The school wants them in early. Financial aid. Those of you who want to send your transcript somewhere to another college or something, all that stuff can't happen until I turn grades in. So there's a lot of pressure for us to take those grades in as soon as we can. So That's what finals week is about for me, is getting all those grades submitted, and then I can go do whatever I want to do because the semester's over, right? So that's where we're at with that. So make sure you understand how the final exam works, okay? Okay, with that said, where are we? So we've got these chapters. We're working on rational expressions. Last time we introduced rational expressions, we talked about simplifying. We talked about, what was the other thing? Oh, undefined. Where is a rational expression defined? Where is it undefined? Remember, it's perfectly normal to have 0 in the numerator of a fraction. It is completely unacceptable to have 0 in the denominator of a fraction. And rational expressions are they're just fancy fractions. That's all we're dealing with. So everything you do in this chapter, and you go, wait, I forgot how to do this. Just think about, what would I do if they were number fractions? And it's the same process. Now, finding the factors is harder. It's easy to see that, 6/8 has a common factor of 2. It's a little harder to find those common factors when your numerator and denominator are polynomials. But here's the great thing. You just did a chapter on factoring, and that's all you got to do is you got to factor the polynomials, and then you'll see what the common factors are from there, okay? So that's what we're doing today, and I guess on Thursday, so we'll be wrapping up this section, this chapter, and then on Tuesday, I'll tell you how the class is going to finish. You'll have your practice test. I'll have the actual test ready to post, and then we can go through everything from there. You can come to office hours, ask me questions, whatever you need to do, and then hopefully finish strong, and hopefully you all pass, and you can all take the El Camino Math 3 that they're offering next semester, I believe, is when they're offering it. I think you probably all know better than me, but I think in the fall it's Math 1, in the spring it's Math 3, where we do the specific El Camino class. So if you're interested, do that. We highly, highly recommend that you take math until you are finished. I think I've probably said this before in here, but it is, we see dramatic drops in the pass rates for students who put a semester in between their successive math classes, because a lot of what you see in this class, you're going to see again in Math 3, but you're going to see it at a harder version of it. Well, if you've just done all this, then Math 3's, you're just going to sail through most of the class. There's a couple chapters at the end that are new, but like the first 3 to 4 chapters, you're just going to go like, yeah, we learned all this stuff. Why are we doing it now? And you're doing a little bit harder problems, but you'll remember most of it. If you wait a year till next fall, you're going to forget most of this, and it's like learning it all from scratch. So we at the school highly recommend that you take your math classes consecutively until you're done. So that it means at least Math 3 for all of you, and then like 99% of you need at least one more math class for college level math, whether that's statistics or whatever. We recommend just get that stuff done, because if you have that gap in there, the pass rates go down. And for algebra, I mean, the pass rates, people who take it like the next semester, the pass rate's like 80%. People who wait 1 or more semesters and then take Math 3, the pass rate's like 40%. So would you rather be in the group where 80% of the people are going to pass, or the group where 40% are going to pass? It's obvious. You want to be in the group where 80% is going to pass, right? Why make it harder for yourself than it needs to be? So I know many of you are in the process or have recently signed up for classes. I highly recommend that one of those be the Math 3 class that's offered in the spring. That's the El Camino math class. Plus, we only offer that class in the spring. We didn't have a Math 3 for El Camino offered in the fall. So if it's only offered once a year, you kind of should take it when it works, or when it's offered, right? When it's there. Okay. With that said, let's get into things. So multiplying and dividing rational expressions is pretty straightforward. I'm actually going to move into adding and subtracting, because I think I talked about the multiply and divide. People don't really have problems with that. People generally get those problems correct. So if you have questions, feel free to ask them and we can take a look at it. But I kind of think that most of you will do fine just by like watching the videos and going from there. The adding rational expressions is very tedious. It's not great. So it's harder, right? It's one of the least fun parts of this entire. Like this is the section where people are just like so glad when it's done. It's harder than solving rational equations, because once we have equations, we have some additional tools we can use. But this one right here is a little brutal, the rational expressions. So that's what I want to talk about here for a little bit. But give me just 1 second. I need to let my dog outside, so I'll be right back. Okay, sorry about that interruption. So what we need to look at is how do we add and subtract rational expressions, okay? So the thing is, it's just like I've been saying for everything in this chapter. It's just what you do normally with fractions. So let's remind ourselves how we add or subtract a typical fraction, and then we'll see it's the exact same process, except like I mentioned earlier in class, if our fraction is 6 over 8, it's real easy to see what the factors of 6 and 8 are, right? We're all pretty good with that. It's a lot harder to just in your head see what the factors of a polynomial are. So what that means is we're going to have to be factoring stuff all the time. That's kind of your mantra throughout this chapter. When in doubt, factor everything. Okay, so if you get to a point where you're like, I'm not completely sure what my next step is. Did you factor everything? No, we'll do that. Because then you can see the factors and you can decide which ones are in common and all that kind of stuff. So this section is tedious because, the truth is with regular fractions, the hardest thing to do is add or subtract them, because you have to go through all this madness of finding common denominators, which is legitimate. You can't add fractions unless they have a common denominator, but it's tedious and it's boring, and it's just not the kind of work anyone wants to do. And now we're doing it with polynomial factors, so it's a little bit harder, but it's the same fundamental process. So let's remind ourselves how this works. All right, so I want to take the fraction 3/5, and I want to add to it the fraction 2/7. Okay, well, I can't add those two fractions together. Why? Because they have different denominators. And why is that a big deal? Why can't we add things when they have different denominators? Well, remember that denominator is saying how many pieces your whole is sliced up into. Like imagine we have two pizzas next to each other, and one is cut into 5 equal pieces, and one is cut into 7 equal pieces. Well, it's pretty hard for us to compare those pieces because they're different sizes and they don't line up nicely and stuff, right? So we can't really compare them very well. But what we could do is take each pizza and cut it into 35 pieces. Then we'd be good, right? Then we could compare them just fine. That's essentially what we're doing what we're about to do here, right? So I look at these two fractions and I say, I cannot add those together. They do not have the same common denominator. So we get a common denominator. And how do we get the common denominator? Well, what we're going to do is we're going to make a list of factors. Okay, so what's my list of factors? Well, I need a 5. And what's my other factor? I need a 7. Okay, well, 5 times 7 is equal to 35. That's the smallest number that 5 and 7 divide into evenly. Sometimes you can get a number that's a little bit smaller, like 6 and 8. The common denominator would not be 48. It would be 24. That's the smallest number that 6 and 8 divide into evenly. But these two numbers are prime, so you're not going to get a smaller number. You're not going to get a smaller least common multiple. So we need both factors in there. That gives us 35. Okay, so now my next step is to convert both fractions to have the denominator that I want. So here's how you think about this. We're going to take the first fraction, and the first fraction is 3/5, and I'm going to multiply by some fraction. And that fraction has to have a special form. It has to have the same numerator and denominator, because when a fraction's numerator and denominator are the same, that means that's really just a form of 1. And when we multiply something by 1, it does not change. Okay? So that's why we can just multiply by something and not worry about balancing, because when you multiply something by 1, you might change how it looks, but you're not changing what it is. Like its value. Okay, so 3/5 times something. So how do I know how to convert this? Well, what we know is that we want to end up with something that has a denominator of 3/5. So it's like this. We've got 3/5. We're going to multiply the top and bottom by something, and I end up with something that has a denominator of 3/5. Okay, well, if I go from 5 to 35, that must mean I multiplied by 7 on the bottom, right? So we multiply by 7. Well, if I multiply by 7 on the bottom, I have to multiply by 7 on the top. Okay, well, so then I'm going to multiply by 7 on the top. And if I multiply by 7 on the top, remember the way we multiply fractions is we just multiply straight across. So that gives me 21/35. So 3/5 is equivalent to 21/35 written as a fraction. Let's see, is that right? Yeah, that's right. Okay. All right, now we have to do the same thing for the second fraction. So I'm going to take the other fraction, which is 2/7. I'm going to multiply. And again, I want to end up with a fraction whose denominator is 35. So you just look at it and go, well, what do I need to multiply 7 by to get 35? Oh, 5. So I multiply by 5 on the bottom. But if I multiply by 5 on the bottom, I have to multiply by 5 on the top. And doing that gives me 10/35. Okay, so we now have converted both of our fractions to have the right common denominator. Now it's easy. Now we're just going to add those together. So we go back to our original problem. Well, 3/5 is equivalent to... we decided it's equivalent to 21/35 plus, and 2/7 we decided is equivalent to 10/35. Oh, something happened here. I have a typo. Okay. So now you add the numerators, keep the denominator the same. So our final answer is that this will be 31/35. Okay, so again, we took this pizza where it was cut into 5 pieces. We took a pizza where it was cut into 7 pieces, and we said, this is nonsense. I can't add these together. I can't compare these things. So we cut both pizzas into pieces of 35 equal pieces. Now everything's the same, and we can compare the pieces from one pizza with the piece from the other. They're interchangeable. We got our final answer. Now with this final answer, we have to double check and ask, can it be simplified? In this case, the answer is no, cannot be simplified. So we're done. If it can be simplified, then you do it. Okay, I get a lot of questions about like, should I simplify this? The answer to that question is always yes. Like you don't even have to ask. The answer is just yes, right? It's kind of wishful thinking. Someone's hoping that the teacher will just say, nah, this one time, don't worry about it. That doesn't happen. Just simplify it. Okay, so you're going to hear me say a lot of the same words and phrases I just did because we're going to do the same thing, but now with polynomials. And let's see what one from the homework here looks like. Oh, looks like some of your homework's due tonight, but we already talked about all that stuff. Here we go. Adding and subtracting rational expressions, level 1. Let me double check. Level 2. I don't want to do that one. We'll go back to that other problem in a minute. Okay, 7 over 2x. Actually, this isn't even the one I want. Let's do C solution. They're not giving me the one I want. Hold on, there's a specific type I want to do, because if you see how to do the one I'm talking about, you can do any of them. Okay. Let's do this one. This is a good one. If you can understand what I'm about to do, you'll be pretty good in this section. Okay. In fact, let's go to a new page. This one's taking me slightly longer to type out. So we're looking at x plus 1 over x squared minus 2x plus 1 minus x minus 4 over x squared minus 1. Okay. Oops, where did it go? Okay, so we want to combine these, and we're looking at the denominator and saying, what's the common denominator? I don't know, because we can't see the factors. Why can't we see the factors? Because it's not factored. So our first step, factor everything. Like I've been saying, just factor everything in this chapter. Okay, so if I do that, let's see, the x plus 1, there's nothing to factor. Okay, x minus 2x plus 1 should be, let me put a space in here. What is that? X minus 1 squared? Yeah, looks like x minus 1, x minus 1. Why does that not seem right? Yeah, that's right. Okay, and then the other one, we've got minus the fraction, x minus 4 over, let's see, x squared minus 1 is a difference of squares, so that's x plus 1, x minus 1. Okay, so we've got our, see how I haven't really done anything. All I did was factor the polynomials that are in the previous version. Okay, so once we've done that, now we can start to figure out our list of factors. So let's see, the first denominator that we need, this one has 2 factors of x minus 1, so we need 2 of those. We need x minus 1 over x minus 1. And then we get to the next list. Do we need another factor of x minus 1? We don't, because we've already got 2, and this fraction only needs 1 x minus 1, so we're covered. We don't need to get more. Okay. So, well, but are we missing something? Yeah, we do need a factor of x plus 1. See how that second denominator has an x plus 1? So we need all those factors accounted for. So that's the new denominator that we're going for, is the x plus 1, x minus 1. Okay, so now we have to convert the existing fractions to have that form. So I'm going to deal with the factored form because we're going to have to factor anyways. So I'm going to grab these factored forms we came up with. Okay, so when I do that, we've got what? X plus 1 over x minus 1 times x minus 1. We're going to multiply that by some value, and from that, we are going to end up with a denominator of x minus 1, x minus 1, x plus 1. Uh-oh. I've got a curly bracket in the wrong place. It should go here. I think that's right now. There we go. Okay, so what are we going to multiply by? Oops, that should go there. Okay, well, what we're going to multiply by is, how do you get from this denominator over to this one? Well, it needs a factor of x plus 1. So we multiply the top and bottom by x plus 1. So then we have to figure out what that new numerator is. So multiply x plus 1 times x plus 1. Don't make that mistake of or people start going, oh, x plus 1 times x plus 1, that's x squared plus 1 squared, right? No, remember your polynomial multiplication from last chapter. You got to FOIL everything out. When you do that, you're going to get x squared plus 2x plus 1. Now, the denominator you can leave factored, but the numerator you can't. It has to be unfactored in order to combine it with our second fraction. So let's look at our second fraction. So that one's going to give us that. We've got x minus 4 over x plus 1, x minus 1. With the same denominator as before. Just making sure I didn't mess up. Okay, so what are we going to multiply the top and bottom by? It looks like we need another factor of x minus 1. So we're going to multiply by what is it? X minus 1. X minus 1. Okay, then we multiply out the top. You FOIL the top. And when we do that, we're going to get what? X squared. We're going to get a minus x for our outer, a minus 4x for our inner, so minus 5x plus 4, which I think is right. Just double checking here because I don't have time. If I mess this up, I'm not going to have time to correct it. So making sure we're on the right track. Okay, now what you do is you add these two fractions together because they have the right denominator. Or in fact, for this problem, it's a subtraction. So I have to remember to subtract them. Okay, so let's do that. Well, just trying to manage time here. So your denominator, we already know what that's going to be. That's going to stay the same. That's not changing. X minus 1, x minus 1, x plus 1. Okay, the numerator. Okay, so what have we got? We're taking this numerator minus this one. So x squared minus x squared. The x squareds cancel out. 2x minus negative 5x. Remember what happens when you subtract a negative? It becomes positive. So 2 minus negative 5x becomes 7x. And then 1 minus 4 becomes negative 3. This is our final answer right here. So you can see we followed the same exact procedure for adding this rational expression together. The only difference is it's harder to deal with these factors when the factors are polynomial factors than when they're just simply number factors, right? Significantly harder to do. So, but it's the same process, right? So let's see. Oh, that was from the book, right? I didn't do the one from here. And then I want to show you these. What about these? Sometimes people look at this and they're like, well, x minus 2 and 2 minus x, that's close enough, right? Can't I just pretend it's the same denominator? No, you can't. So just like 5 minus 4 is not the same as 4 minus 5. They're different. So what you have to do in this case, it's easier than you might think. You multiply the top and bottom of this fraction by negative 1. What that effectively does is turn this denominator into this one. So whenever you see this where the denominators are almost the same but they're in the wrong order, just multiply by negative 1 on the top and bottom. Watch, I'll show you in the solution here. See, they multiply by negative 1 on the top and bottom, and then now after that, look, our denominators match. Right? Because when you add 2 minus x, when you multiply the negative in, it becomes negative 2 plus x, which is the same as x minus 2. So then you multiply that in, and then you just do the problem the same from there, right? So it's one of those things that people get stumped on, and they're like, I don't know how to do this problem. But once they see it, they're like, that's it? That's all I had to do? Yeah, that's it. So make sure you can do those kinds of problems. So next time we meet, which is Thursday, we will talk about, that's not what I wanted. We will talk about solving equations using rational equations, which are actually easier than this, in my opinion. It kind of depends, because in this class, the homework problems they give you for the adding and subtracting aren't too brutal, like you'll see in intermediate algebra. But we get some really helpful tools with equations. Like remember the thing about like adding the same thing to both sides of the equation, multiplying by the same thing on both sides of the equation? Well, in order to do those steps, you need what? You need an equation, right? So actually those will be helpful to us down here, whereas up here when we just had expressions, we don't have an equal sign. So how am I going to add the same thing to both sides of the equal sign? Can't do it if there's no equal sign. So we'll actually have an easier time solving these than we did adding and subtracting these expressions. Okay? So we'll wrap it up there. Anyone who has any questions, feel free to hop into Zoom. I'll answer whatever questions you want about the when the final's going to be, how that finals week is going to work, any of that kind of stuff. Let me know. Otherwise, I will see you in a couple of days, and we will continue with things. All right. Thanks, everybody.